What's up? Welcome to Backend Stuff. I'm Jacob Blitzo. Today we are going to continue writing tests for our Ecto schemas. We need to test two things in our schema files. The Ecto schema, and that would be our defined struct and its types, which we wrote tests for in our last video. And now today we need to write tests for our change set. And this is the code that provides typecasting and all of our validation logic. So let's go ahead and open up our project, Real Deal API. And let's expand the lib directory, the test directory, API, the Real Deal API, schemas, and then open up our account tests.exs file. And you'll see our test from the last video where we make sure the fields and types are what we expect them to be. Super straightforward, and it was only one test. Today we want to write a few tests for our change set function. So let's create a new describe block. And we're just going to call this a change set with our arity of 2, and then do an end for the block. Our first test should test our ideal situation. So we want to receive a valid change set when we give it valid arguments. Okay, so inside our describe block, let's make a new test with the description success : returns a valid change set when given valid arguments. And then we need another do and end for our test block. We first need to pass in arguments to our change set. So if we wanted to get our change set, we can do something like this and just call account dot our change set function. And we need to pass in our account struct and then our valid parameters. So we need to create a map with our valid parameters. So let's put that above our change set here, and we're going to call it valid params. So valid underscore params equals, and then we're just going to have it be a map. So that means we need percentage, opening curly brace, closing curly brace. And as you can see, we're going to be passing it into our change set right here. All right, but we need to create all of our valid parameters. So the first one we're going to need is our ID. And we can generate a UUID here, and we can just use ecto.uuid.generate. All right, and then we need an email. And our email, we'll just make a fake email, test@email.com. And then we need our hash password. You can make these values whatever you want as long as it passes our validation requirements. So like our email requires the email format. So you need the @ symbol, and then insert that. And this just needs to be a naive date time. So if we do naive datetime dot local now, that will be valid, and then updated at, we can do the same thing. Okay. So it's also worth noting here, our parameters have string keys since Ecto casting and validation happen on deserialized JSON. Now that we have our valid change set back, so we're taking this valid params map, passing it in, and we get a change set, and it should be a valid change set. So we can now verify it using assert. And we have, so we're going to just do some pattern matching here with our change set struct. So change set struct, and then opening curly brace, and then we want to know if it's valid. We want to make sure that valid is true, and then any changes made to our struct. And now if this pattern equals the change set that we just created up here, this test will pass. So basically, as long as this pattern right here matches the change set, we're going to get a passing test because it will equal true. So now that we know our change set is valid, we should also make sure our values are what we expect them to be. We also now want to make sure that our ID equals the UUID we just generated, that our email is test@email.com, that our hash password is test password, and that our inserted timestamp and updated timestamp are exactly what we expect them to be. So what we can do is, if you remember last time, we created expected fields with types. We can loop through that. As we loop through the fields, we can grab the value from our valid change set and our expected value from our valid params we just created and confirm that they are equal to each other. So we can just do a for loop. So for, and then we want to pull out just the field argument from our expected fields with types because we don't care about the type. So that's going to be an underscore. And there we go. And then we're just pushing in our expected fields with types map here. And then do an end for our for block. And now that we are looping through each field at a time, we can say our actual value is, we can just use map.get and we can pass in the changes map, which we got back right here. So through our pattern matching, we can actually use our changes. And then we want to know what key we're pulling out of this map. And that would be our current field that we're looping through. All right, so that will get our actual value that we just took from our change set. And then our expected value is just going to be our valid parameters values. So we can just call our valid params map and we can just we need to turn our field, which is an atom from our expected fields with types. We just need to turn it into a string so we can grab the value associated to the string key here. So if we do atom 2 underscore string and then pass in the field, that will be our expected value. So now, like, let's say we're looking at email. Actual will be the email from our change set, so the struct we just created, with our expected email, which is test@email. And these should be equal or our test is not going to pass. So we can do an assert here, and actual needs to equal expected. And if it doesn't, do a comma and we can return an error. So values did not match for field, colon, and then we can pass in the field so we can know what is failing. And then we can do a new line here and we can say the expected value versus the actual value. And then this will show up in our terminal if this test fails. And we're going to do inspect so we can see the whole variable or the whole map if it is a struct or map. So we want to inspect it so we can see the whole object. And this is expected, the expected value. And then go ahead and close that parentheses and curly brace. And then we can just make a new line here and now do actual colon. And we're going to inspect the actual. So we can just see both values that could have failed. And this would just help us debug if this test fails. So let's save it. And I have a typo here, an extra J at the end of expected. Okay. So let's save this. And now let's test or let's run our tests and see what happens. So I need to open up terminal and let's go ahead and just cd into our project. So mine is in documents, development, BS, and then real deal API. And now we just have to run mix test. Okay. So we have 3 tests and 1 failure. And look at that. We actually see our error. So we actually got our values did not match. hash password. So that's pretty cool. Our message is working. And if we continue reading, we can see that test password doesn't equal this hash value. We do know that this is the correct behavior for our change set because it hashes our password before we store it in the database. So now how can we properly test our hash password field? Let's first get our test passing. So we want to ignore our hash password field in this loop. So above our loop, let's just create a list called mutated. So mutated equals, and then opening square bracket. And we want to have our hash password field inside this list. Whoops. Okay, so once we have that, then we can just add a filter to our loop. So as long as it's a truthy condition, a filter will work. So all we have to do to add a filter is do a comma here. And then we want, as long as field is not in our mutated list, then it will go through the loop. So let's go ahead and go back to our terminal now after we save it. And let's just do a mixed test again. And our test should pass. Okay, it's no longer failing. But now we have to make sure our password is hashing the way we expect it to. We are going to need to use bcrypt.verify for this. So let's pass our password from our valid params and our hash password from our change set into the verify pass. So outside of this loop, we can just do our assert, and then we can just call bcrypt.verify password. And then we want to pass in the password from our parameters. So this would be coming from the client essentially, right? So our valid params, and then just opening square bracket, and we have to pass in our key as a string, which is #_password. And then the second value that we want to verify it against is the hashed version of our password from our change set. So we want to hit up our changes dot #_password. So bcrypt.verify, if we click on this and go to it, it returns a true or a false. So if it's false, this test is going to fail. But if it's true, it's going to pass. So why don't we just save this? And we can actually, let's add an error message here too. So we can say that password does not match hash. And what we can do here is say password and then pass in our valid params. I'm just going to copy this. Does not match hash. And then we can just pass in our changes.hashPassword right here too. So we have nice error messaging, and we're going to inspect these two so we can see the whole thing. And what we might want to do is just put a new line here so we can read this right underneath our password. All right, so we have our error handling now. If our password does not match, we'll get a nice error message. So let's go back to our terminal and run these tests again, and we should have a pass. Oh, and we have a failure. So first argument is not binary. So we assert verify password, hash password. Oh, and we have a typo. So it was getting a null. So password. And see, normally it's really easy to just read the error messaging. And if I can type, it'll eventually work. All right, so let's rerun this test and we should have all passes now. So 3 tests have passed and 0 failures. So that's pretty cool. So now if we just wanted to verify this, I'm just gonna remove this and we're going to just type in some gibberish, okay? And I'm gonna copy and paste this value to our error message here. just so we can see how it works. And let's run this test again. All right, so now we can see we got our password. So password test, password does not match hash, and the hash is underneath here. So our error messaging works. And I'm just going to undo those changes and save it. So now we're testing each individual value with expected and actual value. And we're even taking the mutated password into account and making sure that the hash password and the hash password actually are from the same values. So that's pretty cool. All right, so our next test is going to look very similar to our success test that we just wrote. But we want to send different data types that we know Ecto can't cast. A new test with the description error, returns an error change set when given uncastable values. And then do end for our test. And so we need to create a map now with invalid parameters for our change set. All right, so just to speed things up, I'm going to copy our valid params that we created in the test above, and I'm going to paste them inside of this test, but we're going to call them invalid. To make these invalid types, we just, like, our ID can't be a string, even though it's a binary ID, right? But if we did something like naive datetime.local now, that is not the right type, not even close. And for our email, we're going to do the same thing because it's expecting a string. And for our password, we're going to do the same thing. So we're just doing a type that can't cast to a string, okay? You can do other things, but this is the easiest way that I know how to do it. And then inserted at is expecting a naive date time struct. So now we're going to say, let's put a string here. So we're just sending in broken stuff, okay? And then we're going to say updated to a string. Okay, so this is now our invalid parameters. So now we should get an invalid change set back. So we can verify that straight into an assert. So we're going to do assert, and then we need our change set pattern. So our change set struct, opening curly brace, and then valid should equal false this time. And we're not going to get changes back. We're going to get an errors list. We're going to set this equal to our account dot change set, and then we're just sending in our account struct with our invalid parameters. All right, so as long as our pattern matches here, it'll pass because it's true. So these parameters should pattern match to valid being a false Boolean, and then we should have an errors list in there. And why don't we go ahead and run our test right now and see if we get a pass. So now we have 4 tests that pass. And if you see that we just got a warning that our variable errors is unused, which is fine. And we have all passable tests. However, this doesn't actually answer the full question. We want to make sure we're getting an uncastable validation error type, right? So we're going to want to loop through our expected fields with types again. And as we loop through, we want to verify that each field exists in our error list. So let's start with that. We're going to do the same exact thing we did above. So for, and then we're interested in the fields that is from our expected fields with types map that we created. And now inside our loop, all we're going to do is assert that the field exists in our errors list. So if it was nil, it would be false and it wouldn't pass. So as long as it's not nil, it'll be true, right? So if we do assert, and then in our errors list, we're just passing in the field atom that we're getting back. And as long as that value exists, this test will pass. So we'll have a custom error message here. So the field, and then we can pass in the field that we're cycling through so we can read it in our error message, is missing from errors. We don't want it missing. So that means if it is missing, one of our values is being casted or isn't sending an uncastable error like we expect. So now if we save it and run our tests, they should still pass. And we're still getting our fourth test passing, which is pretty freaking cool, guys. All right, we're not quite done though. So this verifies that the field has an expected error. But to take this one step further, we can make sure the error type is a casting error. So we can pattern match and grab the metadata, which has a key value list, and we can make sure the validation type is cast. We have our current field that we're on, and we can now pattern match and grab our metadata out of our errors. So we have our error list, errors, and we're grabbing the current field map. So this is returning a map, and the second value in it is our metadata essentially. And inside that meta list, there is a key called validation. And that validation, that's the validation error. It should equal cast. And if it doesn't equal cast, then it's not a cast error. So we want to assert that our meta list with our key validation equals a cast error. Because if it doesn't, that means the validation type, and we can just go ahead and meta. We're going to print the validation type. So if it's not cast, it could tell us that it's something else. So we want to make that it's not cast, okay, is incorrect. Okay, so our test should all still pass. So let's run them. And we still have passing tests, and we're making sure that they're cast errors. So I could change this to any like cat, and we should get our failures then, because cast is not going to equal cat. So the validation type cast is incorrect. So that's pretty cool. So our custom error messaging works, and we'll just undo that and keep it cast. In this test, we are just testing that all of our variables that are passed in return an uncastable error with the change set. Okay, we need to write one more test for our change set. We need to make sure that we get the correct validation errors when required fields are missing. So let's copy and paste our last test here, this one. And we're going to just give this a new test description. It's going to be error returns an error change set when required fields are missing. And in this case, I'm just going to delete invalid, and we're going to delete all of our parameters. Okay, so all of our parameters are now deleted, and we're just passing in an empty map. And instead of invalid types, like last time where we got casting errors, we should get a required error instead of a cast error. So we're going to loop through our expected fields types still, and we're going to still say that the field is missing from the errors if we expect it to be. And then our validation here in our meta data needs to be required instead of cast. Okay, so now let's run this test and see what happens. So save it, pull up your terminal, mix test. Oh, I forgot to change this from invalid to just params. Is there anywhere else that is? Okay, save it. Let's run it again. Our first assert failed because our field ID is missing from errors. If you remember from our last video, we had to make ID updated at and inserted at optional because they're not created until they are inserted into our database. So we're going to have to ignore those three fields and loop through the expected fields and filter out our optional values again. So let's add an optional list, just like we just did the mutated up above. We mutated and ignored hash password. We're going to add optional, and we'll do it right under our params. So we're going to make, we're going to put our optional values in as a constant list up here so we can use it throughout our test file if we need to. And these are our optional fields, and that is ID, inserted at, and updated at. Okay, so now we have that list created, and we can filter it out just like we filtered out our mutated value in the for loop, just like that. So we're going to go down to our for loop, and we're going to do comma, and then we're going to say field, not in, and then at optional, because our optional list is now at the top of this module. So now our tests will pass, but they're just ignoring the optional values that are getting returned in our error list. So let's go ahead and just make sure they pass. Okay, so now we have our fifth test is passing. Right now, all we know is we're ignoring our optional values, but we are not proving that they're not in our error list. So we have to do a refute. And this gives us a passing test as long as the condition to the right is false or nil. So what we're going to do is underneath this for loop is we want to just do another for loop where we have access to our field from our optional list this time, not our expected fields and types. And what we want to do is we absolutely want to make sure that our optional fields are not in this error list. So we're going to do a refute. So if this is nil or false, the test passes. And then we're going to pull up our errors list and pass in our field, our key, okay? So if this is false, this test passes. So we want this to be a nil value. So, and then we'll make a custom error message here, the optional field, and then we'll pass in the field that we're checking is required when it shouldn't be. When it shouldn't be. Okay, so what this test does is it makes sure that we're not requiring optional values. So let's save this and let's run our tests. And we should still have 5 passes. And there we go. We have all passing tests. And your challenge is to write all the tests for our user schemas change set. You learned everything you need to complete them. And of course, the solutions can be found in GitHub if you get stuck. As always, if you need help or want to check out the solutions, check out that GitHub link in the description. And if you have more questions or want to hang out and chat, join my Discord server, Backend Stuff. That link is in the description as well. If you want to learn how to build scalable, production-ready APIs, hit that subscribe button now. See you next time.